Hello, it's Super Easy Math. In this video, we will talk about adding and subtracting square roots, so let's get started. You might be wondering what is the relation between this picture and our topic. You will see in this video. The main rule that we want to discuss before simplifying the square roots is this rule. So square root of a plus square root of b, is it equal to square root of a plus b? For example, square root of 1 plus square root of 3, is it equal to square root of 1 plus 3, which is 4? So let's see. We know that 1 plus 3 is equal to 4. Instead of 1, we will write square root of 1. And 3 is equal to square root of 9, equal to 4 is equal to square root of 16. Now if we apply this rule, just adding the radicands, we will get 1 plus 9 equal 10. So square root of 10 equal to square root of 16. In your opinion, is this true? So can we say that square root of 10 is equal to square root of 16? Of course not. So we can't apply this formula because we will get a wrong answer, as you see. Let's go back to the previous slide. So radical 5 plus radical 10 minus radical 3. So adding square roots of different radicand is as adding an apple to a calculator to a cake. I mean, it's not useful to add them. What's meant to add those things together? We won't get anything useful. We can add, for example, an apple to an apple. For example, radical 5 plus radical 5. So here we have same radicand. Imagine as if we are adding an apple to an apple, we will get 2 apples. So the first thing you should take into consideration when adding square roots that they should have the same radicands. Let's take some examples. Before we take an example, let us talk about these numbers. I prefer to call them golden numbers. What's special about these numbers is that their square root is equal to a natural number. For example, square root of 4 is equal to, square root of 9 is equal to 3, square root of 16 is equal to 4. However, the square root of 5, which is not a golden number, is equal to 2.36 whatever 5. So you'll get an infinite number. Let's look at this example. So here we have different radicands. We can't just say 20 plus 45, 65 minus 80 equal to minus 16. So it will be radical minus 16. This will be wrong. What we can do is just look at 20. We'll search for factors of 20. One of them is a golden number. For example, 20 can be written as 2 times 10. But neither 2 nor 10 is a golden number, so we will not take it. 20 also can be written as 4 times 5. 4 is a golden number, so we will use these factors. So we need one golden number. So 20 can be written as square root of 4 times 5 plus 45. So 45 can be written as 9 times 5, and 9 is a golden number, so it's acceptable. Minus 80. 80, we can write 80 as 2 times 40, but neither 2 nor 40 is a golden number, so we will not take it. We can write it also as 16 times 5. So 16 times 5 is equal to 80, and 16 is a golden number, so it's acceptable. The second step is to get out these golden numbers outside the radical. So we know that square root of 4 is equal to, so 4 will become 2 outside the square root, and here we have only 5. The same here, so if you want to bring this 9 outside the radical, it will become 3 because square root of 9 is equal to 3, and we have here 5. Minus 16, it will become 4 because square root of 16 is equal to 4. And the last step, now they have the same radicand, which is 5. We can add them. So as if we are adding 2 apples plus 3 apple minus 4 apple. So 2 plus 3 is equal to 5, minus 4 is equal to 1. So 1, and we will put the radicand, which is square root of 5 or square root of 5. Another example. So here we look at 50. 50 can be written as 5 times 10. Neither one of them is a golden number, so we will not take this factor. We can write it also as 25 times 2. So 25 is a golden number. So 6. 25 times 2 minus 2. 8 can be written as 2 times 4. And 32 we can write it as 4 times 8 and 16 times 2. So here in this case we have 4 is a golden number and 16 is also a golden number. We can take any of these two factors, but it's better to take the biggest one, so the biggest golden number, which is 16, not 4. So we can write it as 16 times 2. So we will get now these golden numbers outside the square root. So 25, if we get it out, it will become 5. Multiplied by 6, we will get 30. Minus, so this 4, if we get it outside, it will become 2. Multiplied by 2, it's 4. This for 16, it will become 4. Multiplied by 5, 20. And the last step, we have the same radicand. We will add the numbers outside. So 30 minus 4 equal to 26. Minus 20 equal to 6 square root of 2. And the last example. So for 3, 12 can be written as 4 times 3 minus 2. 48 can be written as 6 times 8, but neither one of them is a golden number. We can write it as 16 times 3. So 16 is a golden number. Just look here. Here we have a 3 and here we have 3. Then the third one we should have 3. So 75, it's 3 times one of these golden numbers. So 25 times 3 is equal to 75. Now this 4, if we get it outside, it will become 2. Multiplied by 3 equal to 6. 16 outside will become 4 times 2 equal to 8. And 25, it will become 5 times 5 equal to 25 square root of 3. Now they have the same radicand. We can add the numbers outside. So 6 minus 8 equal to minus 2. Minus 25 equal to minus 27 and square root of 3. If you like the video, please hit the like and subscribe button so you encourage us to upload more videos. Goodbye.